All right, so all of the code in zip.js, since we're on a new branch, it's going to be okay if we just remove it completely. So we're going to start fresh here. So only thing that you should have left after removing all the code is just the basic constructor and then our module.zip export pattern of sorts down below. So we're just wiping everything clean from our zip.js file. This is gonna be a lot of fun. What I'm gonna do to start is I'm gonna create a neighborhood totals object to be able to keep track of the of each neighborhood and what its count currently is. Because from that, I'm going to be able to generate this top 5. I'm going to create a top 5 array. Notice the context difference here. I'm attaching the top 5 array to the zip object, which we know is going to get exposed to the window. The neighborhood totals object, I'm deliberately keeping that within our closure, within our IFI, because it's something that I don't feel is relevant to have exposed, because it's something that we're just going to use internally. It's not going to be a part of the exposed application. Therefore, I don't need to attach it to zip, and it's going to remain private.
Do we need to have the variable in front of it?
Yeah, I'll do it for you. If that makes you feel a little bit better. Okay.
And because if you don't declare var, it becomes a global variable. So just
Well,
inside the IFI.
not inside the IFI.
Okay.
Yeah.
That's my question.
Yes. But in terms of just consistencies, we can have the var in there and all as well. Okay, so we've set up two variables here. So we know that we need data. So far very familiar here. I'm kind of working backwards here, but let me show you where I'm going. Okay, so I'm going to create a function called return props obj, which will take in an object and it will return a new object. And within this, I can assign properties however I want. I'm going to pause just for a second because that was a lot.
Keep letting me make that line not so long.
I'm proud of this line.
Well, I mean, just like,
Can you just
go on to the next line.
clarify what the question marks do?
Yeah.
I've forgotten that is what.
Yep, we're going to talk about it. Okay, so what is happening on this line? What are we actually doing?
We're checking whether the object or the property, there is an address or if there's not. And if there isn't, if it's not an address set there, which means there is an address, then it's going to set that address to the address. Or if there's not an address, it's going to be undefined.
Right. So
Slow down, Dylan.
It's like
That's like 22.
well, I know, but it was like not.
I think you got too much water in the cup on one of your cups and no coffee in the other cup right now. No, it's okay. All right. He's exactly right. This is what is this? What did we call this operator with the question mark and the colon? What's the name? What's the name of that operator? It's a ternary operator. And what the ternary operator does is it will actually return a value. It will attempt to return a value based on the conditions that we provide here. But it's essentially asking a question to the left of that question mark. So it's saying, do we have this address property on that object? So the double bang will return truthy or falsy based on that value. So if it's an empty string, we're gonna get false. But if we get Greenwich Village, we're gonna get true. Or in this case of the address, if we get Rockefeller Plaza, we'll get true, and it'll be assigned to that address property that we've just built out here on the fly. If it's an empty string, it's going to go to the right of the colon, and it's going to pass in undefined.
Why don't we have length at the address?
Down here?
Oh, the object properties address dot length on the address line.
Keep going.
Which part? I'm sorry.
Like just right before the question mark.
Right here?
Yeah, don't we need length there?
Nope.
No.
Yeah, we're just checking. We're just checking to see if the value exists. So, for instance, if the value comes back as just an empty string, then we're essentially running this, which will give us a false value back. So then, with that false value, we can assign this undefined property to there, which is a little bit more meaningful to us than just an empty string. A little less confusing, a little less error prone in our application as well.
So the bit after the question mark only runs if the first bit is false.
But it's just one or the other.
Oh. Wait.
So it's
Oh,
either
right.
either that.
Yes. So if we do have an address from this evaluation, this will apply. If we do not, this will apply. Yeah. So ternary operators are actually really powerful, and sometimes much more favorable than just a simple if statement. They're a lot more expressive. So we're doing a similar task here with the neighborhood property, in that we're checking for the same thing, except we're actually picking up on the length because we want to see if there's actually anything in there.
But neighborhood is also a string, right?
It is also a string. So we could theoretically do that as well. Which I think is why you were asking about the other one too, right? Yeah, between the two different length ones. So again, if we do have that, then we're going to apply this to the value. So what this is doing is it's going to split based on the comma, but then we're going to splice and only include everything after or just before only that one first value, and then we're going to join it back up. Stephen had a similar approach, but he was just including, once he got that array, he was just specifying the zero based index to only include that very first one after we run the split on that neighborhood string. And then again, if we don't have anything here, then we're going to pass in undefined. Now, we're not quite done with this object, because we can also pick up on coordinates while we're at it. Now this part might look a little strange because I'm specifying the second value of our coordinates first, and the first value second. So in GeoJSON standard format, it's actually longitude first, latitude second. But if you ever work with Google Maps, they like to have latitude first and longitude second. So this is a very common trip up. So I'm actually refactoring this to expect the data in case we want to apply some markers to a Google map. We are formatting it in the way that Google actually likes it to be.
And everybody else in the world. By
Right.
the way.
So we've actually sanitized our coordinates now into a friendly object that we can actually now just reference with this coordinates property whenever we want to add a new marker to our Google Maps. All right. Let's add another function. We're going to call this function populate totals, which will take in an object.
It's not function.
Function. It's a super function. Okay, so this populate totals is going to, it's expecting an object, and so we can run a for in on this. And we're going to expect it to be looping over the keys of the neighborhoods in that object. And then we're going to push into that an array with the information that we have on that neighborhood. And then we can sort it. And I'm going to reference a function that we don't currently have, but notice how we're slowly but surely making this very composable. Instead of just throwing in a bunch of random functions, we're actually we're going to be referencing functions that are going to be doing smaller pieces of tasks for us. So this is again what we call loose coupling, being able to create little different pieces that can do tiny chunks of code. So if we have any errors or fixes we need to make, we can clean those up in little parts and not one massive code base that we need to kind of dig through. I'm going to leave that there for now, and I'm going to add a good comment here for us for later reference. Okay, so we referenced this highest function in the sort. So we'll go ahead and write that out. So function highest, which will take in current neighborhood and next neighborhood. And we're referencing a number, so we actually need to get the second index from each of these, because above we're actually pushing in another array here. So we have an array, but now we have this array that's kind of nested in between there, and so we want to actually sort based on the number and not accidentally the neighborhood itself. So that's the difference on line 33, is we have the neighborhood that's going to be listed out, but then we're also going to be including the count of that neighborhood that we're pushing into this top 5 array. So we want to be able to sort that based on the 5 highest. Now while we're down here, let's ensure that we make a request to actually get the data, because we haven't invoked our request out to the server. And I'm going to actually write another function, because I want to turn this into a friendlier readable object. So I'm going to go ahead and start a comment that will kind of dictate where we go from here. So we're going to transform the top 5 array of arrays into a readable object. And we'll write a function called statsFriendly. and it will accept a stats object and a current array. So this is actually what we're going to be passing into reduce, which we haven't called yet. But we can add it to this populate totals now. And we can declare that as zip.top5. So we're going to reassign what zip.top5 looks like with reduce. And since we already have that function called statsFriendly, we can pass that in, and now we can actually specify our accumulator to be a literal object that we build out when statsFriendly is invoked. Do we have anything that's actually counting for us though right now to actually get this running total? Because we have this neighborhood totals object, but we don't have anything that's doing any counting for us. So we need to create that as well. So this comment will say create a running tab of neighborhood counts. So we're going to build out a counter, just a counter object. That might be referred to as a dictionary in Python. All right, so we'll call this function the count. Yeah. Which will take in a zip object, just a placeholder. And what we're going to do when we're looping through this object, we're going to be checking every time to see, one, do we have a neighborhood that's currently in this counted object? So do we have a reference to a neighborhood that already exists? So initially we can actually check first to see if there is a neighborhood property, and we'll pick up on that dynamically. And if there isn't a neighborhood that's on this object, then we were going to set this. And what are we going to set that value equal to if it doesn't already exist? So let's say we have our counted object in place, and let's say the very first neighborhood we come across is the financial district. So initially the object is bare, therefore this if statement will pass. So we want to be able to set financial district equal to what value if we're just trying to count these neighborhoods.
Is this the first time, did you say?
Yeah, so we'll set it to 1 if it doesn't already exist. Otherwise, we are going to add to it because it already does exist. So we can utilize our double increment operator. So now that we have this function, let's actually go back up in here to our collection, our retrieval, our initial retrieval, because we called return props object on our initial data set, and we know that return props object gives us this new object back based on the properties that we want to pick up on now. The only ones that we care about: the zip code, the address, the neighborhood, the coordinates. And so now that we have this new object back, we can run a for each on this, and we can simply call our count function. So we can invoke the count on each of these objects. That will then build out the totals for us. Because neighborhood totals is an object, and all we're doing is dynamically, in that count function, we're just dynamically checking to see whatever object we passed in, if it has that neighborhood value right here. So note the bracket notation because we are trying to pick up on dynamic properties. So if it's not there, we'll set it, and we'll set it equal to 1. Otherwise, if it already exists, we'll add to it.
Where is it going?
It's going to be going into this neighborhood totals object. Yeah. So by the time count finishes, then we should have a collection of each neighborhood with the total number of zip codes that it has. And then after that finishes, we can invoke populate totals, and we can pass into it our object neighborhood totals. So let's pause for a second and actually take a look at that populate totals function that we wrote out. So here's populate totals right here. So populate totals accepts an object, and our object is the neighborhood totals object that the count was actually doing all that hard work for us. So when populate totals gets invoked, it's going to take that neighborhood totals object with all the counts. It's going to loop over the keys, the neighborhood keys, and it's going to push into that array that we started off with. It's going to push into it the neighborhood, so that is the key, and then it's going to push into that the number as well, because this will evaluate to a number. So this is just a key, but when we reference it in the context of the object that we passed in, we're going to get an actual number back. So if it was financial district 30, we're going to get the neighborhood as financial district, and then we're going to get the value of financial district. So we'll have an array with the neighborhood and the total.
So now top 5 is going to be a 2D array. Well, no, it's going to be an array of arrays, right? Neighborhood name.
Yep. It will be until we run this part right here, this stats friendly, which will essentially reduce that down into an object for us because we call stats friendly here in reduce, and we're able to set our accumulator type to an object. Should this work? Are we missing anything? I'm gonna save that. Don't ruin me later. D7. Data. Status. Bonus. Okay, so top 5. So there we have it in order. Top to bottom, Midtown, Financial District, Chelsea, Garment District, Upper West Side. Lots of Midtowns and Financial District zip codes there.
Almost there. Or were you just gonna do it as an object rather than an array?
Yeah, I changed my mind. I was like, I wanted an object
Is it
instead.
harder to do the array part because then you have to like, well, I guess it's not that hard to sort that in order, but it's like because you can't choose the order. For
Right.
these, then you have to move it and then sort it.
Right, because we do our sorting right here with this helper function highest, which is going to sort it based on the actual number, because we're getting an array initially of the neighborhood and the number, so we want to be able to sort based on the number and not the name, which is what we can do here. And then with our reduce, we can actually transform this into something that's a little bit more friendlier, which I kind of like. I actually kind of like how this reads. But notice how we broke this up into a series of functions. Now you do have to do a little bit more work to actually kind of know what's going on. You have to actually step into these other functions, right? Because they're not going top to bottom. But if we needed to update any one of these, we could do very easily. I'll publish this, by the way, and the video.
Rick, can I see the object again? The final object. How come?
I think we're off. Didn't you have 38?
Yeah.
Well,
Yeah.
that's because, well, did you count the city that you dropped off?
Oh, yeah, that might be the case.
Yeah.
Yeah, I guess I
So you
did.
had counted all of them, even the ones that had to.
Oh, yep. Yeah, I eliminated mine first and then counted, but you counted before then. Yeah. Yeah. Nice. And that's kind of the neat thing about this is once you have your data, you can determine what makes sense for you and apply it accordingly. What questions do you have about this? Okay. We're past the top of the hour. We're going to take a few minutes and then we're going to jump into our blog articles. We're going to run through it all. And then we'll break for lunch and meet Alan. Careful, microphone.
A little one? Yeah.
Back on it. Okay, so we discussed earlier that a stack is kind of just like a series of plates where when we step into another function, it gets placed on top, and when the execution of that function completes, we say it gets popped off the stack. So what type of data type does that sound like? Exactly, just like an array. And in fact, you utilize stacks every day in your text editor. Undo, redo. You're literally pushing and popping off of the stack memory in your editor's application. So, in our application, we're going to walk through relatively quickly what this actually looks like when we start up our blog. So for instance, if we had a site like this pulled up and we enter in our URL, what happens first when we enter in that name for the URL? Do you remember the piece from the HTTP talk? How do we know what Google.com, for instance, is referencing? How does the browser know? Or yeah.
Go into the DNS.
The DNS. That's right. So the domain name servers. So it's gonna try to map that name to a literal number, just like it would a telephone book. So Google.com would literally point to an IP address that we can associate with. In the case of our blog articles application, however, do we need the DNS? At least in the form that we've been running it so far.
Go straight to the IP address in the local host.
We can bypass the DNS because we already have the actual address, which in the case for us is just the our local host, our 127.0.0.1 address, our home address. Has anyone seen the doormats? There's no place like 127.0.0.1.
Wow.
I want to get one. I don't have one currently, but if you want to nerd out, you can get one. So since we don't need the DNS, we already have our address. We can bypass it, and we can actually begin rendering content. So when we walked through this briefly earlier, we say that we kick off a new web request response cycle with each asset that we are looking for. So each CSS file will actually start a web request response cycle. So you know what that means? What are the three parts to every request? Yep. URL, method, and header. So our URL is going to be our link here. Our method by default in the browser is what type of request? Which method? Get request. And then with that, any additional metadata that we want to pass along to the server. So the server accepts that request object. It builds a response. And what are the three main parts of that response object? So with every what if we have a bad request? What if we get a 404?
Yeah.
Status, right? So status is part of that. And then we said, what else? Status, headers, and the body for our content. So this first one, we got a 200. And we got the actual CSS as our body, the actual contents of our CSS file. And that's just one request. So we do the same for this, and for this, for this, and for this. Now, in development, we're okay with having a bunch of files, but when we go into production, in large-scale production environments, we actually want to minimize the amount of requests that we have to make. So what you might see in production level code is we squash these into actually one large file. And we do what's called minification. So we actually bring everything together, we remove the white spaces, and we shrink it down into one file. We're therefore reducing the number of server calls that we have to make. And on top of that, you might have heard of the term obfuscation, which will actually change variable names to something a little bit smaller. So we're dealing with concepts of saving resources in this case, and we do it with JavaScript files all the time. In 301, we won't be as concerned with that, but in 401, you have build tools that will do this for you. And some editors even have these build tools installed as well, so you can actually see what that looks like. You can minify your files, you can obfuscate your files. But for now, we're just making a series of extra requests. We do the same for our fav icon here. Now when we get to our actual script tags, there's not much going on in this case because there's just content. It's mostly HTML readable. Same with our base level HTML tags, the H1, the body, our unordered lists, header, main, section tags, everything. The browser's like, yep, bring it on, all good. We can continue building out the DOM right here. Now when we get to jQuery, we kick off a new web request response cycle. So hopefully we get back to 200, and hopefully we get back the contents. But now once we have these contents, we actually have to hand off to what we call the interpreter to actually parse through the JavaScript. So in the browser, what's going to be doing that interpreting for us? For Chrome, for instance. Mm-hmm. Or the V8 engine that is a part of Chrome to be able to interpret that for us. So we will step through the code as the interpreter, and at the end, we will hopefully have this attached and available to us to the window. So we can hand it back up to the window, continue building out our DOM, step to the next one, do the same thing with handlebars, attach that to the window, get our other libraries that are associated with the application. Again, web request response cycle each time. Now here's a local file in article.js. So we're going to do the same for that, but we need to not take anything for granted because this is all open for, it's all out there. It's up for grabs. So when the interpreter hits this file, it's going to actually step through just like it did with all the other libraries. And it's going to walk through these functions, these declarations, anything that's being assigned. It's going to actually walk through these. Now, currently, we just have a series of definitions that are occurring. So we're not actually executing any code at the moment. So we're just running through in what we call the creation phase for the interpreter. We're just actually going through and just making sure we have all of this in memory for us. All of these function definitions. And we'll do the same with article view as well. So here's our object, here's a series of definitions. Note that these are also within Now in this case, just to easily see where we actually begin executing code, I've literally placed them out in the open right here, just for the purposes of demonstrating the walkthrough today. So this is where we actually add something to our execution stack, this article.create table, to actually begin the process of rendering, populating our data. So you can follow along if you want, if you have some notes out, we can add it to the stack as we go along. So we'll start at the bottom. With article.create table. So we need to actually go into article.create table here. This is the first time that a user is coming to our website. So article.create table begins its execution, and the first thing that it hits, what are we doing here?
Calling to the library.
Yeah, we're calling a method. webdb.execute. So we need to add that to the call stack. So we're within create table, but we've just added another function to the stack. So we add that to the stack. So we run through, parse our SQL commands. And when that's done, we execute this anonymous function. So we need to add that as well. When this finishes right here, what happens? When we finish this console.log statement, how should we update our stack, our execution stack? Function gets popped off. So we've completed that part. All right, so here's the end of that function. So that gets popped off. So far, so good. Now, what about 36? What's the end of 36? Yeah, what do we complete here? What function are we currently within still? Yeah, so we're finished with that. So we pop that off the stack. So all that we're left with now is our create table. We hit the end of that. Currently, there's nothing else running except the context of the window. So where do we go? Is that it?
Back to the script file. Probably back to
Yeah, let's actually go back to our index because we actually have another method here, right? So after create table finishes, we actually add something to the stack now. So we're going to build that back up. So article.fetchAll now gets added to the stack. Right? Okay, now what happens? What do we hit first? I need a stack manager. I'm doing a lot of walking already.
WebDB.
webdb.execute. Gets added to the stack. We have some conditionals here. So when the user first comes to the site, are we gonna have this already? Because we've set up our table, but do we have any information in the table? We just ran create table,
There's no rows.
but but we don't have any rows, therefore we're going to hit this else. And when we hit this else, what happens now? Ajax call. Who calls Ajax? jQuery. But let's make sure that we are in the right context. Here's webdb.execute. Here's webdb.execute. So we're still calling jQuery from within that, so we add it to the stack. Our get JSON. Okay. So we make a request out to our data. Do we run this immediately?
No.
This get JSON? Or the callback function?
No.
No, we don't. Here's the end of that, right? So while this is actually processing, we temporarily exit. We temporarily exit out to finish off any code. So do we have anything else going on right here? Nothing right now. So browser and interpreter is like, all right, we're just going to hang out for a second. Maybe have the Ajax spinner going that we built out until what?
It's the request.
Yeah. Until we hit this callback. So the data comes back. We get a 200. Everything's okay. We're still within get JSON, but now we're hitting this anonymous function, this callback function. Which is scoped right here. So now we're within here and here. So with that data, that response data, we're going to call for each. Well, what's for each? Method, another function. Got to add it to the stack. Okay. Now let's make sure we're in the right scope of for each. But what does for each accept? A function. Need more whiteboard space. Getting close. How deep can we go? All right. So within this now, we're setting a article variable, and we're passing into that article variable the result of instantiating a new article based on that record in our response data. For each record in that response data, we're going to build out a new article constructor according to our specifications. So, what happens on 103?
This is the object constructor.
The constructor function. And how many times do we invoke that constructor function?
Response 7.
Yeah, 250 times. So here's our stack. We're going to hang there for about 250 times, right? So we're going through all of this, back and forth. For each one, new article. But also, we're doing a little bit of juggling, right? Because every time this completes, we pop off because now what are we doing? I'm going to put these on the same line. Because we're alternating between the two each one pops off, the other one takes over temporarily. But now we are in a different execution environment. We are now in insert article. We're in this insert record method on the article variable that we created. So when we actually invoke insert record, what's the first thing that happens in insert record? So I'll add this on top of insert record. We run all of the code right here. That gets popped off. So we complete insert record. We go back to new article. So we've just inserted one article record. We hit the next one. Insert record, webdb.execute, SQL command, pop it off, back to new article. Now we have two articles. Go back. Okay, I think we got it now. All right. So if we go back now into, where are we? Right here, right? We're still in new article. So let's assume that all 250 are populated and we've inserted those records into the table. So we are now finished with what? How's our scope look here?
Finish with the for each function.
Mm-hmm. We look at for each. So we're finished right here, right? So SQL command is done, insert record is done, article constructor is now done. Anonymous function that for each called is now done. Our for each, is that done? For each is right here. What about this anonymous function, right? Because now we're walking back. We're tracing back. This anonymous function, our callback function. It's down here, so we have yet some more code to process, right? So we have all of our records inserted into the table now. But we're still within this anonymous function, and within this anonymous function, we get to do what? What's next? What's the next line of code that we hit? Another WebDB. It's kind of an important deal, this WebDB, isn't it? Okay, WebDB.execute, we run some SQL. But now, what do we hit after we run the SQL? Another anonymous function. We've selected everything from the articles, which we're now expecting to get an array of objects back in the form of rows. So now within this anonymous function, we call yet another method, article.loadAll. On rows. So when that completes, but before that completes, actually, we need to step into article.loadAll, don't we? Because that function's not present right here. So here's loadAll. So now within this, we call map, which gives us another new article instance here. And thankfully there's no other code because I'm running out of room in the real estate space. So we pop that off, we pop the map off, and we pop load all off. So we've completed this. We're still inside the callback function. Now we need to call next. How do we know what next is? Who calls next? So fetch all invokes next, so therefore we need to see where fetch all was called, which is down here in this case. Article view.render index page. Here's our render index page function. Next, aka render index page. Article.all articles dot for each. Function. Now we're stepping through some more jQuery. So we're in the context of jQuery, so we add that to the stack now for each of these, which is going to conditionally append our filters, our options, and our selects. It's also going to append our actual articles. But notice within each one of these, we're within jQuery, but we're also within this toHTML method. So we need to step into that function now, which is provided to us on the article. Here's toHTML, which we're calling handlebars within toHTML. So we're now about right here. See how deep we are in our stack trace now? We call handlebars, the compile method, and then we step into yet another jQuery method too. So we just keep adding to the stack here until one thing completes, and then we pop off the other function calls. So let's assume all of that rendering is done, and we've returned that template. Let's go into render index page. So we've rendered everything right here, but now we need to actually set up these event listeners and these other pieces that we incorporated in with jQuery. So everything else has been popped off for the most part, but now we add these to the stack until each one completes. We pop that off, add it, pop it off, add it, pop it off, add it, pop it off. But we're not taking anything for granted. We're actually looking at all of these. So handle category, right here. We're going to actually run through all of this. Add it to the stack, pop it off. Handle author filter, same as the category. Handle main nav, where we're actually setting up our listeners. We're stepping into that. Set teasers, where we actually truncate our article body. So notice now these are being called after we've already rendered everything to the page. Therefore, we have access to these elements with the DOM and with jQuery. So if we pop render index page off the stack, which we know from our context now, that was next. So that completes. We know that load all has already completed. We were within the context of the anonymous function, the callback from our select. We're now done with that. So this is done. WebDB.execute is now done. Moving back up here. Our anonymous function from getJSON is now completed. There's nothing left for getJSON to do now. So that has completed. Our WebDB.execute also done. Is there anything left in fetch all to do? Opening, closing, everything's been executed. We pop that off the stack. We look at index. The DOM finishes with the closing of the script tags. Is that it? So there's our finished blog articles application. Notice all the work we had to do just to step through all of those methods and those functions. All of the work we've done so far, we literally took the time to go in and dive deep and think like the interpreter and add it to the stack. And when things completed, we removed them from the stack. The browser's doing all of this for us in milliseconds. And we had to do all of that in 45 minutes roughly. So this is what we mean by tracing the execution path, of not taking anything for granted, not taking any single line of code for granted, and walking through it. Next Friday we'll be doing that. Next Friday we'll be pairing up and actually walking through different pieces of code and actually commenting out what's actually going on and how a piece of code is being executed and who's calling that code, where in the application is the code being invoked. It's a really, really good exercise. There's a lot of value in that. Any questions on what we just did? What questions do you have about this process? I'm going to have this published soon. I don't have it officially up yet, but this will be the assignment you can complete over the weekend or in lab this afternoon. So the lab for today will be our second peer review evaluation. So similar to last week, look at your most recent partner's pull request from their file or any issues that they may have created internally from the self-reflection assignment and help them add to that and provide meaningful feedback and good comments on their code. So the goal for that will be to help each other out. And then if you choose to do so, you can work together or separately on the part 2 for the testing assignment. So nothing has changed in terms of our framework. We still have our expect function here. And we have the same example test. So part 2 is the Hungry Lion Challenge. So this says as long as the lion is well fed, he doesn't care too much of the humans that pass through. Unfortunately, the new caretaker is a little absent-minded. The lion needs 4 meals per day on average to stay happy. You're going to figure out how many days it took before the lion decided to supplement his diet with the caretaker. Sad face, sad face. Okay, so here's a meals per day array that is logging the number of times the lion was actually fed. And we've set up this variable called toHungryDay. That's going to be the day that the lion essentially did terrible things to the caretaker. So the to-do says to cycle through the days in meals per day, and at each day, print out the number of meals per day the lion got since the new caretaker started. So toHungryDay should receive the number of days before the lion started pondering protein supplements. That is to say, we want to know the first day the average actually gets below 4. Now we've actually set up a test already, and this is just a type of expression to make sure that the number that we're actually assigning to is an actual number data type. So if we do some weird funky math or we actually haven't built anything out yet, the test will fail at first. So the goal is to then make this test pass by just ensuring that the number we're getting back is a number. But that is not all, because once you get that number back, you want to write a second test expecting that the number that was assigned falls within an acceptable range according to the actual array that we started with. So remember to pass in the expression and write a failure and a success message for each of those. So I'll be pushing this up after lunch today, and I'll send the link out. So this is another fun testing exercise. And just working with data, just data types and other things. So. How does that sound? I haven't done any thumb meter checks. How are we doing today, thumb meter wise, just in general? Cool. Nice. That's good. Oh, and yes, the whiteboarding will continue this afternoon. Dylan, Sarah, Steven, and Crystal. So 1 o'clock, 1 through, and actually, Crystal, we can do 2 o'clock. Yeah. So we'll try to stay on schedule with that. Any questions before we break for lunch? So again, the lunch and learn is going to be in Sam's corner. It should be starting probably pretty soon, actually. So let's break.